Hi, welcome back to Curious Planet. This is the second video of 3 in my Igneous Rocks Deep Dive series. So if you haven't watched the first one, go back and check that out and then come right back here. If you are up to speed, you remember in the last video, we talked about the origin of many of the minerals that make igneous rocks. But I purposefully left out a lot of the minerals in that series of formation just for the sake of keeping things simple and not bogging down the lesson with funny names. But I would be remiss to talk about this topic without covering that series of minerals, because it's a foundational topic in igneous petrology. It's something called Bowen's reaction series. Okay, so in 1922, this scientist, Bowen, figured this out. It's exactly the thing we were just talking about. Let's put temperature over here. This is high temperature. And as we're moving down, the temperature is decreasing. This is still hot, it's still magma, but relative to up here, colder temperatures down here, okay? So we imagine as a mantle plume rises through the crust, its temperature starts to go down. And do you remember the first mineral to form as the mantle plume starts to cool and crystallize is olivine. We'll write it again. Okay, olivine's first one in, first one out. Then remember we talked pyroxene, next one to form. These are early. These are using magnesium and iron. Remember our early forming mafic minerals, deep earth conditions, magnesium and iron rich. Okay. Then we have a mineral called amphibole. This is still a dark mafic mineral. In fact, let's just write the next one too. The next one's biotite. Amphibole and biotite. This is like black mica. You might have seen it in granites and stuff before. All of these minerals are mafic, deep earth minerals that form with magnesium and iron. The difference between them and why this one forms, then this one, then this one, then this one, is the crystal structure. Remember I was saying olivine is just a single one silica tetrahedron. Pyroxene is, they form chains like this. Well, amphibole, it becomes a little more complicated. These are double chains, so imagine 2 of these piled up. Biotite is a phyllosilicate, so these form in sheets, like these wide sheets of silica tetrahedrons. Just know that each step down is an increase in the complexity of the crystal lattice, and that's why it's one after the other. It's like a very distinct and discrete, stepwise reaction series. This guy figured it out. Okay, so then after biotite, we're gonna get into our felsic. So remember, these are lighter in color, higher in silica, more complicated crystal structures. The next one to form is potassium feldspar. I'm gonna write K-spar because it's easier. Just know that this means, that's a weird name, but feldspar is probably the most abundant rock forming mineral on Earth. It's freaking everywhere. This variety is potassium rich. K is potassium on the periodic table. That's why we call it K-spar. Okay, after K-spar comes a mineral called muscovite. Muscovite is also a phyllosilicate mineral, just like biotite. Why don't they form one after the other, you say? It has to do with water. Muscovite needs water to form. It's a hydrous mineral, and there's not enough water in the mix until later on because it's not being used by all this other stuff. So the longer the Pluton is rising and precipitating out minerals, it's starting to be concentrated more and more in basically the materials that aren't being used. One of those materials is water. Finally, at this point, there's enough water for muscovite to form. Kind of weird, but that's the reason. After muscovite, we have our favorite, quartz. Quartz doesn't care. Quartz is just like I'll come in last, I'll form wherever, little veins and stuff. It's just everywhere. It just infills any space it can. It's like the garbage can mineral. It doesn't need anything other than silica and a couple oxygens. That's it. Super simple, but the crystal structure is very complicated. That's why it's the last one to form. One thing to know on the chemistry side, remember our mafic minerals are using magnesium and iron. Our felsic minerals on this side of Bowen's reaction series are using potassium, we talked about that, and aluminum primarily. Yeah, some of these minerals can be called like aluminosilicates. So this is the discontinuous Bowen's reaction series. This series happens one after the other. Olivine forms, then pyroxene forms, then amphibole forms, then biotite, K-spar, muscovite, and quartz, and then the opposite. If the rocks start getting shoved back into the mantle and everything starts melting, quartz melts first, then muscovite, then K-spar, biotite, amphibole, pyroxene. Olivine's the last one to melt. These are comfortable in the mantle. These are comfortable at the surface. These are the last to erode, first to melt. These are the first to erode, last to melt. Does that make sense? Let's talk about the continuous side of Bowen's reaction series, because there's two sides. It's continuous because it's being formed by just one single mineral. That mineral is called plagioclase feldspar. Remember I said feldspar is wicked abundant, forms tons of rocks. There's many forms, but basically two primary categories: plagioclase or plage and potassium feldspar. Those are kind of the two families that we talk about. But if we look at the continuous series, basically it's different forms of plagioclase feldspar. And what form will precipitate out of the melt? Well, that depends where in the earth the melt is. Is it deep and hot? Well, then we're gonna get versions of plagioclase feldspar that are calcium rich. Is it shallow and cool? Then we're getting plagioclase feldspar that is sodium rich. The most calcium rich version of feldspar is anorthite. But anorthite's kind of cool because the earliest earth was primarily made of anorthite, such that this is what the moon is made out of. Pretty rare in the modern earth. This is like a proto-earth mineral. Kind of cool. Towards the end here, in our felsic part of the continuous series, we have sodium-rich plagioclase feldspar. That's called albite. Albite, super common. There's a bunch of plagioclase feldspars in between here. I'll write them. You don't have to memorize them. Okay. There's this whole spectrum ranging from calcium rich to sodium rich, deep earth, shallow earth. Yeah, that's the whole series if you want to know it. Igneous rocks, this is it. Like, if you wanted to understand the process that makes igneous rocks and how mantle material undergoes fractional crystallization as it rises towards the surface, it's this. This is it. So if this is a topic you're interested in, become very familiar with Bowen's reaction series. One fun way I kind of like to think about Bowen's reaction series is a bag of trail mix. You know, like if you're a healthy adjusted person, you would just like reach in and grab indiscriminate handfuls of trail mix and then eat them. And then just like every bite would have a certain number of every ingredient. But if you're anything like me, then you just eat the M&Ms first. You just go through and pick them all out, right? Well, the M&Ms in that case are olivine, right? This is a bag of trail mix. And as this mantle plume starts to cool, it picks out all of the easiest, simplest, densest minerals first. That's olivine. I pick out all the small, colorful, delicious chocolates first. That's the M&Ms. And then next would be like the peanuts and then the almonds. And then at the end, I'm just stuck with like a depressing bag of salty raisins, right? Like, because I ate all the other good stuff first. I didn't, you know, make it a mix. Well, that's how this goes, right? Like Olivines, the M&Ms, and then we have like, the nuts here, pyroxene, amphibole, biotite, etc. And then the quartz is just salty raisins. Like you've already picked out all these other minerals, and so the elements required to make them are gone, and then the leftovers turn into quartz. I don't know if that helps. Okay, I hope that was helpful. I hope you learned something, but I know that was a lot of weird mineral names and maybe some new concepts. So if you have any questions, please don't hesitate to leave them in the comments, and I will do my best to answer them. And until next time, stay curious.